Hello there, this is Mr. Bainey, and this lesson is 10.1 Properties of Dilations. The standard is 8.G.4 up at the top right, and the essential question, how do you describe the properties of dilations? So a dilation, this is our fourth transformation. Remember that from Module 9, we have three different transformations: translations, reflections, and rotations. I'm going to refer to those um, throughout the next couple lessons. So go back and watch my videos if you're still having a hard time um, understanding how the other three transformations work. Remember that dilation, this lesson is the fourth one and final one that we're going to look at in this class. So it's going to, in this page, define what a dilation is. So a dilation is going to result in a different size figure. Um, and if you compare that to the previous three transformations, where the image ends up being the same exact size and the same exact shape. Okay, here we're going to get the same shape, it's just going to be a different size. And so if we take a little bit closer look at some of these pictures right here, then you'll see that in, for example, the triangle, the rocket picture is a good um, image for you to look at and try to understand this a little bit better. But if I start with this blue triangle right here, we're making it bigger, and this is the image, right? So the blue one's the pre-image, and this is the image. Notice it's the same shape. It has like the S right here looks like a right angle. S prime has a right angle, 90 degrees right here. Okay, all the angles are all the same, and the sides are actually going to grow proportionally, right? So if you're thinking like if RS grows to R prime S prime, say this is like, it looks like it's made about twice as big, that means the other sides are going to get twice as big. This point C right here at this corner, we call this the center of dilation. And you can think of this as like a projector, right? Or when you're when there's a source of light, think of like making finger puppets, right? Like using shadows. Um, if this projector is projecting this image right here, and let's say it goes to the wall or the whiteboard, in this case in my classroom, then it's going to look like this. It's going to be much bigger. Okay, so that's how dilations work. Think of it as a projector. Okay, so let's take a look at the explore on this side, and let's explore how these dilations work. And I'm not going to complete this whole thing because you're going to see some similar results as I go through this table. We have a quadrilateral here, a shape with four sides. This blue shape is our pre-image because of the way it's labeled. We got A, B, C, D. And then we have A prime, B prime, C prime, D prime is our image, this green one. So let's fill in this table based on where these points are. So A prime is this green one right here. That is the point -1 and then up 2.5. So it is -1, 2.5. That's the x coordinate and the y coordinate. So remember that when I plot points, I have something that looks like that. Okay. Point A, right? I'm still filling in this first row. Point A is this blue one at the top. That is the point -2, 5. Okay. Now the way we think about dilations is what happened from our pre-image, that's the blue one, to get our image. What did we do to this shape? Okay. And you could also think of it as, I have point A is these numbers I just found. What did I do to these numbers to get these numbers right here? And the way we figure that out is, in these last two columns, is we're going to find the ratio. And ratio, think of that as like a fraction, okay? Ratio means fraction. We're going to divide the image, right? You see here it says A prime, B prime, C prime, and D prime, divided by the pre-image. So that means the ratio or the fraction of the x-coordinates means I'm going to take this x-coordinate, this is my image, divided by this x-coordinate. So it's going to be -1 over -2. I could divide it, I could change it into a decimal if I wanted to, but it just becomes 1/2. Because negative divided by negative is positive, and so I just get 1/2. Okay? And I'm going to do the same thing with the y-coordinates. Well, the first y-coordinate, the one for my image, is 2.5, and then the one for my pre-image, is 5. So I got 2.5 over 5, which comes out to the same decimal, or the fraction of 1/2, same thing. Let's just do one more point. So B prime, if I look at my graph again, the blue one, B prime, is the point 2, 1, and point B, the blue one, is the point 4, 2. So if I were to take the x-coordinate of the image divided by the x-coordinate of the pre-image, I get 2 over 4, which is 1/2. And then when I take the y-coordinate of the image divided by the y-coordinate of the pre-image, I get 1 over 2, which is 1/2, right? I don't have to reduce that at all. So you'll see that I am always going to get 1/2. What I would encourage you to do is to fill out the rest of this table, the C prime and the C, right? Divide the X and the Y coordinates and see if you keep getting 1/2. You notice that that keeps popping up, all the ones that I've circled there. Here's another interesting feature of dilation. So I'm going to highlight on here. Blue, this D, going from D to C here on the bottom. Take a look at how long that is. And it is 8 units long, right? It's 8. Then take a look at D prime, C prime. And I chose this side because it matches or it corresponds to the one on the bottom. And that one is 4 units long. Okay. Well, if it goes from 8 to 4, how are we doing that? What are we multiplying by? And some of you might think division. We're dividing, right? We're dividing by 2. But dilations, we like to keep it just kind of consistent and use multiplication. You're actually multiplying by 1/2. So here you would do 4 over 8, right? That's image divided by pre-image, and you would get 1/2 again. So not only do you can you look at the specific points to find this 1/2 number, you can also look at the lengths of the sides. And notice I only did one of them. I can do the other ones, and I will always get 1/2. So what is this 1/2 number? What does it do for us? Well, the scale factor is something that's going to show up in the next lesson, you'll see. And the scale factor of this dilation ends up being 1/2. So this word scale factor is the most important number when it comes to a dilation. In fact, it's really the only number that you're going to deal with. So let's give it a try. Before we take a look at the example, I wanted to point out the vocab words that we have here. Oh, scale factor is actually right here. We just talked about that a moment ago. So when we do a dilation, remember that we're making the shape bigger or smaller. And the technical terms it gives you here is enlargement, right? That means making it bigger. And making it smaller is a reduction. And we use a scale factor to help us describe how much bigger or smaller something is getting, right? We don't just want to say it's getting bigger. We want to say how much by how much is it getting bigger? Is it getting twice as big? 1.5 times as big? Is it getting 5 times as big? And so on. Okay, this your turn here. If you want to give this a try, we have to find the scale factor of this dilation. Try it out, think about it a little bit before you see the solution. Okay, I'm going to offer a couple ways that you can think about this. You can pick any side from the blue shape, right? That's our pre-image. Let's do DG. Okay, any side you want. But then you'll also have to pick the corresponding or the matching side in the green shape, which means D prime, G prime. The length of DG is 4, and the length of D prime, G prime is 2. So how do I get from 4 to 2? Well, I take the image divided by the pre-image, and I get my scale factor. Okay, and it's just a coincidence that we're getting the same number here as we did in the Explorer. It's not always going to be a half, right? When you're dividing, you'll get your fraction or your ratio. Another way to do it is if I look at, let's say, point E is 10, 10, which means I'm going to look at E prime right here. E prime is the point 5, 5. Okay, so also helps us out that they're the same numbers, right? The x and the y are the same number. So I'm really doing the image divided by pre-image, which means if I'm just going to focus on the x coordinates, the image is 5, the pre-image is 10. And notice I get the same number. So my scale factor is 1/2. Okay, the work that I did here on the side, I showed 2 different ways. You don't always have to do that. It's a good way to check your answer though, if you do know how to find it multiple ways. But this is almost like justifying my thinking, showing my work and how I got the 1/2. So be sure to do that when you're practicing this and going through your homework problems. Okay, and that's it for this lesson. Thank you so much for watching. I hope this helped you in understanding what dilations are and how to work with them. Have a great day.